morning. Tom just complained about the fact that the date on my slide is wrong. It's not May 30th. But I was supposed to give this presentation yesterday, and then this happened. So I wanted to fly from Frankfurt to Berlin, when suddenly there was a really weird smell of burnt oil in the cabin. And one engine was shut down, and we aborted our flight to Berlin. We cruised a bit, we dumped some fuel, we had an emergency and landing, which is not really an emergency, but redundant engines. The redundancy of the engines was no longer a given, so that makes it an emergency, although it's a standard procedure. So we landed, there was lots of fire department vehicles and whatever. And then a couple of hours later, I was able to fly to Berlin. So, good morning, and now I have fixed the slide. Are you happy now, Tom? Good. Hi. My name is Sebastian, and since the end of 1998, early 1999, I'm doing things with PHP. I learned programming and the love for programming, most importantly, a really long time ago on Amiga computers using M68K assembly, and then later some C, some AREX, some basic dialects in between. And some of this information may be relevant at later points in this presentation. So I like to help teams successfully develop software. That's the reason why I founded, together with Arne and Stefan a couple of years ago, the PHP consulting company, and that's all the advertising and sales information that you're going to get out of me. If you would like to know how we can help you, find either of us throughout the conference. We're here until Thursday. So lots of question marks on the board. Lots of questions around what type of language PHP is. Over the last couple of years, at countless occasions, at user group events, at conferences, whenever I meet PHP developers, there is most of the time the question like, so what type of language is PHP? How does it compare to other language XYZ, and what do terms like dynamic or static or weak or strong typing or manifest typing, expressive typing, explicit typing, implicit typing, type inference, and whatever, what do these terms mean? Why should I know what they mean, and how can I use them to compare languages? So I was really surprised that this presentation was accepted when I proposed it for IPC. I'm really glad that I get the chance to talk about that. And apparently there's lots of interest, so that's good. So here goes. Still trying to wake up. So I'm going to try to answer these questions organized into a couple of different chapters. First will be, how is a program written in one language executed? Let's talk about execution. Over the decades that we now have programming languages and computers and can run programs on machines that get ever faster, there have been various different execution models for programming languages. And it all started really, really simple. At some point, so there are basically nowadays 4 different types of execution. You can parse the source code, which means first you scan a text file that has source code in it. You read it character by character until you recognize a word. That's what the first step of a compiler does. And then at the end of that first pass, you have a sequence of so-called tokens or words that then a parser tries to make sense out of. It's the parser that tries to answer the question, do these sentences, these sequences of words, make up valid sentences, valid constructs in this programming language. And after that, we have some other representation of that program code that we can directly execute. This is, for instance, how BASIC works, or at least the really, really old original implementations of BASIC. Or this is how PHP used to work before PHP 3. The original PHP, personal homepage tools, and version 2, PHP/FI, they executed a PHP program by reading it line by line, and if what was written on that line made some sort of sense to the PHP interpreter, it would be executed immediately. And yes, this means that if you have a for loop, for instance, and the for loop starts on line 10 and ends on line 20, you execute lines 10 until 20, and then on 20 you realize, oh, the for loop ended, so you backtrack 10 lines and see whether or not the loop condition still holds, whether or not you need to execute this again. Then you do it all over again, which is, of course, redundant and slow and not really a nice way of executing code, but that's how it all started a really long time ago. You can take the source code and do some of the parts that I just described. You can scan it, you can parse it, you can generate an intermediate representation and execute that intermediate representation. And if you then have a for loop, you only ever analyze the source code to get that intermediate representation that you can actually execute once. And at the end of the program execution, you throw everything away. This is the default execution model for PHP since version 3. It's still the default in PHP 4, PHP 5, PHP 7, with the addition that we can now, thanks to bytecode caches, tell PHP to not forget about this intermediate representation at the end of the request, but cache it somewhere. So we really do the expensive compilation to get the intermediate representation only once. And of course, you can compile the source code and not generate something intermediate to run, but generate machine instructions that you can save in the binary that contains the machine code that is required to run something on a particular hardware platform. This is, for instance, what you do with a programming language such as C or C++. It's not what you do with a language such as Java or C#, for instance. Yes, there you have an explicit compilation step, but the result of that explicit compilation step is not a native binary that you can execute. It's a binary that contains the intermediate representation, in the case of Java, the Java bytecode. And then you have an interpreter, the Java runtime, that takes this bytecode and executes it. At least that was the original model for how Java was executed. Modern Java runtimes take this bytecode and on the fly compile it to native code to make it faster. But at the end of the day, if you look at it, it's still some sort of interpretation, unless the optimizer starts to kick in and does just-in-time compilation to machine code whenever necessary. So that's execution. And there are only 4 major flavors, what we just saw. It gets more interesting when you look at paradigms. So any idea what programming paradigm PHP follows, or which programming paradigms PHP allows? Shared nothing, that's basically an architecture paradigm. So what type of language, on a language level? Object-oriented, yes, but is it just object-oriented or can it do something else? Imperative, yes. Okay, it's too early in the morning, not everyone had coffee yet. And It's me standing up here, so I should do the talking. I know I'm lazy. So let's talk about programming paradigms. Oh, CSS, you got to love it. So one style of programming is called declarative programming. And that's a style of building the structure and elements of computer programs that expresses the logic of a computation without describing its control flow. And that's something really interesting and powerful because it frees the programmer from having to think about implementation details. When I write a query to get data out of a relational database, I do not want to care about what the most efficient way is to get that data, to minimize discrete, to order and sort and whatever. I don't want to care about that. I just want to write down, give me the information that I want. So that's much higher level, if you want, and farther away from the machine than some other languages. That's what SQL does, for instance. So I want to be just able to write select star from programming languages where paradigm equals declarative. I don't want to tell the database how to perform the steps or even what the steps are to answer this question. Here's a question, give me the answer, I don't care about the implementation details. Similar concept, well, it's the same programming paradigm, declarative programming, but in a different type of application is what you do with Prolog. And as surprising as that may be, Prolog is still used today, although it's really, really old and really, really weird, but you can do really powerful stuff with it. For instance, you can put research from marine biologists about how dolphins and whales communicate with each other into a Prolog knowledge base and use that to translate between humans and dolphins. It's really, really interesting, and if you're interested in that, there's a book that talks about this, 7 programming languages in 7 weeks. Really interesting. So with a Prolog knowledge base, you have knowledge in there, and then you can ask questions like, are Sally and Erica siblings? And nowhere in the knowledge base have I explicitly written that down, but there are algorithms involved that deduce that information. Really powerful. But that's not how we program in PHP. PHP belongs to something else. So if you have declarative programming on the one side, on the other side, you'll have imperative programming. And imperative means I tell the computer what to do and exactly how to do that. It uses statements that change a program's state. So I have to care about state, and I need to tell the computer through the program how to change that state. So PHP is imperative, as somebody from the audience mentioned earlier. And how did imperative languages evolve? It started all the way back with writing directly machine code. When we got the first computers, there were no programming languages. I mean, it's a chicken and egg problem. I have a computer. Before I had the computer, I had no way of running software. Now I have a computer, I have no software. Now I need to write software. The first thing that I'm writing probably not going to be a high-level compiler that can do a transformation that is necessary from a developer-friendly language to something that the hardware can understand. So the first machines were exclusively programmed using machine code. Like really, really, really low-level instructions for how the computer should operate. The first abstraction that we got over that at the end of the 1940s was assembly language. And yes, that's still low level, but if you look back at the time, that was really, really high level. It was much farther away from the hardware. It was inconvenient to use because still you had no concepts of modularizing your program. It was basically a huge list sequence of statements. That got a bit better in the 1960s when macros were added to assembly. Now it was suddenly much more convenient to write assembly code. But still not fun, maybe. At least you're weird like me and like doing low-level assembly, 3D real-time stuff on the Amiga. Around that same time, another programming paradigm or a refinement, so imperative programming split into different directions. One of those directions was functional programming. This is a paradigm that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. And for a programming language to be considered truly functional, you need to have 3 characteristics. It needs to have support for higher order functions, which means you need to have a first level entity called a function, and you need to be able to pass around functions as arguments to other functions, and need to be able to return functions as the result of a computation that happens in the function. That's characteristic number 1. Number 2 would be purity. So as you're not allowed to change state and you're not allowed to mutable data. And that's really leads to a conundrum because there are a lot of interesting things that I can do with a language that cannot talk to the outside world. But also for most real-world use cases, that's really, really hard. So you have to, in intelligent ways, break that purity and put all the nasty stuff that deals with the outside world into quarantine. And the third thing is recursion. You need to be able to have functions that call themselves. And a couple of languages evolved. Some of them, well, most of them are still in use today. Common Lisp is really, really interesting because already in the early 80s, just like Smalltalk, it had runtime features that other programming languages, like Java, for instance, came up with like 5 years ago and touted them as, this is a breakthrough, no other runtime ever had this. Like, replace bytecode at runtime while the application still runs. That's not something new. We had that a really long time ago. But okay, to each their own. And yes, people use Haskell, people use OCaml. Funny enough, so apparently there are regional preferences for programming languages. I have yet to meet a developer that likes OCaml that does not come from France. So OCaml comes from a university in France, and all the students that go there, or most of the students that go there, learn OCaml, and are really, really happy with that. And it's a really powerful language, but it's kind of weird. So that's functional programming. So PHP is not a functional programming language, yet it allows you to do some sort of functional programming or functional programming to some degree because it has support for things like lambda functions and closures, and you can pass them around, and all that works. But of course, PHP is not a language that gives you a guarantee of purity. You can change state. You can mutate data. There is no language-level support that prohibits the change, the mutation of a value that you put into a variable after it has been created. And of course, PHP can do recursion, but not as optimized as some of these functional languages can. And at least for me, it's not a bad thing that PHP is not a fully functional language. It's nice that I can use things like lambda functions and closures, especially when I work with built-in functions in PHP that do sorting and filtering and so on. That's really convenient. And for me, what we have in PHP to accomplish that is enough. But other people have other opinions. So there were some refinements to imperative programming. First one was structured. So a programming language is considered structured if it is imperative, but gives you convenience features that make it easier to group statements into sequences, you have language constructs to make a selection, like I want to branch here or I want to branch there, and I want to do that without using goto and just jump around. Iteration, like loops and recursion. And one of the first languages that had that was Algol in the late 50s. Became much more popular with Pascal, and then later Modular 2 and Oberon, the whole category of what people consider the Wirth languages, because all three of them that I just mentioned were created by Nikolaus Wirth. But these languages also influenced, for instance, Kernighan and Ritchie when they designed C. So all of these languages that are listed here are imperative structured languages. So, of course, PHP is structured because it's imperative. It has for, while loops. It has the if statement. It has a switch statement, and so on. So, imperative, structured. What next? What can we think about? Somebody mentioned earlier object-oriented, but we are not there yet. That comes a little bit later. The next thing that people desired when working with programming languages and doing development. So structured was already a big step up because finally it could easily do things like an if statement or a loop and so on. But there was one important thing missing that we take for granted today in programming languages, and that was the concept of routines or subroutines or functions or procedures, whatever you want to call them, a block, a sequence of statements that you can assign a name to, that can have arguments and a return value that you can then use for reuse. Before that, it was all copy-pasta, right? If you wanted to reuse code, you copy-paste it. Or yeah, I think that we had editors already that allowed copy-paste. Otherwise, you had to do it by hand. But you had to duplicate code. Let's put it like that. So, and of course, languages like BASIC, like C, had support for procedures. And of course, PHP is procedural. And while it became popular in the late 80s, it's not something that only came out in the late 80s, came out in the late 60s. And it's interesting to see that it sometimes really takes 1 or 2 decades for a new concept to catch on, to prove that it's worth thinking about that and applying that. And of course, it took some time to find an implementation in a programming language that led to widespread use. So object orientation came out in the late 60s in languages like Simula and a couple of years later in Smalltalk. And this is a programming paradigm that uses objects to encapsulate data and operations. And an object-oriented program, is built around the idea that you have objects that send each other messages. So it goes a little bit beyond just having procedures that you explicitly call, whereas now you have an object represents something, hopefully something from your domain. And if you want to do something, you send a message to that object, and as the sender of that message, you no longer care about how the implementation works of getting the thing done that you want to get done by sending that message. So PHP is object-oriented, at least since PHP 5. Yes, you had most of the keywords necessary and most of the language constructs, the syntax and the semantics available in PHP 4, but it was not really great. Only with PHP 5, 12 years ago, that became really a viable approach to developing software with PHP. But there is not just one object-oriented paradigm. It has separate sub-paradigms, for instance, class-oriented. So PHP is a class-oriented, or PHP has support for class-oriented, object-oriented programming. What this means is that objects are built based on blueprints that you have written down as classes, and inheritance happens on the class level. You can inherit from, or a class can inherit from one parent class, not like in languages such as C++ or Common Lisp. You cannot inherit from multiple parent classes, and that's a good thing. At least it's a good thing that you cannot do it the way you have to do it in C++. Would be okay if you were able to do it like in Common Lisp, because the Common Lisp object system is built around Lisp, and the Lisp runtime lets you rearrange and customize the core semantics of the language at runtime. So your program could say, I want multiple inheritance to work exactly like this in my project, so I do not run into all the common problems that multiple inheritance brings with it. But I think that's out of the scope of this presentation to go into all these problems. And it was these problems with multiple inheritance that led the designers of Java, for instance, to say, no, we do not want multiple inheritance. We do not want multiple inheritance of implementation. But what we want to do is something else to get what most people want from multiple inheritance, which is multiple inheritance of interface. I want to be able to express that a class provides multiple interfaces. And yes, PHP also supports that. And since PHP 5.4, we have something called traits, which is a feature for horizontal reuse. So we can have sets of methods that we can mix in at various points in our class hierarchy and get multiple inheritance of implementation without multiple inheritance of type. So that is another approach to solve all the bad problems with multiple inheritance in a language such as C++. I just mentioned the word type. And that's where things with regards to differences between programming languages become really interesting. For what I'm going to talk about now, bear in mind that while there are many different approaches, there is not one right approach. At least over the last 4, 5, 6 decades, neither the academic world of computer science research nor the practical world of people building software to get things done have agreed on what the best way is to handle the concept of types, or most importantly, how to enforce rules based on types in the programming language. All of them have their pros and cons, so let's get through them. First of all, what is a type system? A type system is a collection of rules that assign a property called type to various constructs a computer program consists of, such as variables, expressions, functions, or modules. So if I have a variable, that variable contains a value, and that value has a type. If I have a variable and I assign an integer to that, then that variable has the type integer. Now, there are languages that allow me to, on the next line, assign a value of some completely other type to that variable, where other languages don't allow me to do that. So this is what a type system is about. And as I mentioned, there are many different types of type system. So, for instance, there is explicit typing, which is more commonly referred to as manifest typing, because the type information manifests or is manifested in the source code of the program. And those are programming languages that require you to provide type information in the source code for each construct that can hold, or where a type is relevant. And though there are a couple of languages that use that, like C, C++, Java, and C#. So for instance, if I have a Java program like this, it has a method. That method has an argument named other. Now, if I have type information there saying that if a parameter from the outside is passed to this method as an argument, the types have to match. The type of the parameter has to match the type of the argument. So if I pass something other than a money, I get the compile time error. I have a local variable named sum. I cannot have a variable in Java without declaring its type, without telling the compiler explicitly what types of value I want to hold in that variable. At the end, I return a return value, and that return value is of type money. And again, that type has to match what I explicitly declared the return type of this method to be. Now, contrast this example with PHP 4, which is implicitly typed. Implicitly typing basically meaning not explicitly typed. I have a class named money. That money class has a method named add. That method named add has an argument named other, but I have no type information. So now, at some other place in my program, I can go and create an object of type money and call the add method on that and pass something as an argument that is not money object. That leads to fatal error. Sorry, by the way, for that output. I do not have PHP 4 anymore. So I wrote PHP 4 style code and ran it with PHP 7. The error itself will be the same, but the text will probably be different. But I hope that's okay. Couldn't get PHP 4 to compile on a 2016 Linux system, so. And hopefully I'm the only one that has that problem and nobody's using PHP 4 anymore. So I get a runtime error. So whereas a language such as Java is able to tell me at compile time, because it has all the information it needs at compile time, hey, you're doing it wrong. You're calling something that wants a money object with something that is not a money object. Fix this. In PHP, I get that problem or reported at runtime. But not because it can detect at runtime that the type of the object doesn't match, but it fails because that method does not exist on the object that was passed. And I would get a totally different error when I would pass something that is not even an object. So back in the PHP 4 days, and that maybe for some of you a trip down memory lane, is you had lots of code like this. You added a guard clause. There was a function called isA, so I could ask, hey, is this variable, does that contain an object of that type? And of course, back then, PHP 4, we didn't have exceptions, so we couldn't even throw an exception, so we had to use trigger error to signal, hey, you called me with something that I don't want. But that error message is already better than what I had before, because instead of, yeah, you passed me something, and I tried to call a method on that, and that doesn't exist, now I get, hey, I can tell you, I want this, and you give me that, and that doesn't match. Much more helpful. So with PHP 5 added support for type declarations for function and method signatures, but only allowed it for certain types. It allowed it for class names, interface names, PHP 5.1 introduced array. At some point later, we got callable. But here, we just now have a method named add. It has a argument named other, or a parameter named other, and that has now a type, and that type is money. And when I try to do what I did before, now I don't need my own guard clause anymore. There is a PHP now does that itself. It doesn't do it at compile time, like Java does, for instance, but it does it at runtime. So I get a runtime error, argument 1 passed to money add must be instance of money instead, in instance of std class given. So I already mentioned earlier, opposite from explicit typing, we have implicit typing, and that's a type system which requires few or no type annotations, meaning type declarations of variables, object members, function arguments, etc. And there are a couple of those languages out there. Basically, that's what people refer to when they mean dynamic languages. And dynamic languages come in all different kinds of flavors. So you get functional dynamic languages like Common Lisp. You get something like PHP. You get something like Python. And the list could be really, really long. There's an interesting mix if you couple implicit typing with something that is called type inference. So you don't require the developer to put the type information explicitly into the code and empower the compiler, make the compiler really, really powerful to deduce from the information that is there which types the developer meant. It infers the types, and based on that inferred information, it enforces types at compile time. And for instance, Haskell and OCaml do that. There's currently work being done as part of PHP 7.1 to add type inference to PHP. Not necessarily, at least not yet, to do what languages like Haskell or OCaml do, be it at compile time or at runtime to enforce rules of the type system, but to improve the optimizer of PHP's compiler to generate better opcode, optimized opcode, optimized bytecode, so that execution is faster. But maybe at some point in the future, that same information generated through type inference while compiling PHP source code into PHP bytecode could be used to enforce type rules at some point. Interesting stuff. So that was dynamic. Was it? What did we talk about? No, that was explicit versus implicit typing. Sorry. Now we come to strong versus weak typing. So a language uses strong typing. That's basically what Barbara Liskov, who you should be familiar with, because the L in solid principles for good object-oriented design, the L in solid, the Liskov substitution principle, that's Barbara Liskov. Whenever an object is passed from a calling function to a called function, its type must be compatible with the type declared in the called function. And that's what you have in languages like Common Lisp, C++, Python, Java, and C#, for instance. It's not something that you have in C, for instance, because C is weakly typed, which is surprising to some people. So what does this mean? It means that, for instance, in Java, if I have code like this, I declare a variable named D and tell Java that I want to store a double in there. And then I declare a variable to hold an integer. And then I want to assign the value that is a double to the variable that holds an integer. Those are incompatible types. Java doesn't allow me to do that. It tells me, go fix your shit. There is no auto magic casting going on behind the scenes. So I have to do explicit casting. I have to tell the compiler, yeah, I know about the loss of precision when I convert from a double to an int, but ignore this for this statement. Please cast it down from double to integer. And the weakest description for all of the things that I'm talking about here today that you can find is for weak typing. And you see that I didn't even bother to put one there, because the most useful one that you can find is everything that is not strong typed is weak typed. But there are different types of weak typing to make it more interesting. So for our context, since PHP draws a lot of inspiration from C, both C and PHP are weakly typed. That means in C or in PHP, this would not be a problem. We would not have to add the explicit cast. Of course, we can add the explicit cast. It's just optional. It just happens behind the scenes if you don't put it explicitly there. So PHP is weakly typed. Another interesting aspect is, when do we enforce the rules of our type system? There's, for instance, static type checking, which verifies the type safety of a program based on analysis of source code. So that is due to static code analysis that happens at compile time. And that's what you get in C, C++, Java, C#, for instance. If you have a Java program like this, int I equals true, Java compiler won't let you do that. Tells you, nope, those are incompatible types. Not going to do that for you. And if the compiler tells you, no, I'm not going to do that for you, it aborts, and you do not get a binary. You cannot get this type of error at runtime. You get it at compile time. You'll never be able to execute a program that has a problem like this, because your compiler will not generate something that you can execute if you have a problem like this. So PHP is a little bit weird when it comes to static versus dynamic, because where we are able to do type checks at compile time, we do. Like, for instance, with the new void return type that was added in PHP 7.1. Don't ask me why we didn't have the void return type in PHP 7.0. It should have been there. It was forgotten. It came too late. And there was no consensus to put that into 7.0. So PHP 7.1 basically makes the return type declarations introduced in PHP 7 much more useful, makes them complete. So if we have a function named f in this example that says, I do not have a return value, and if at some point in the code there's a return statement, that is something that violates the void return type declaration, and that is something that I can detect, that the PHP compiler can detect at compile time. And at compile time, you will get an error. It's not something that we have to wait to detect at runtime. So that's good. So dynamic type checking means verifying the type safety of a program at runtime. And that's what dynamic languages do. That's what Common Lisp does, that's what Python does, that's what PHP does, that's what Perl does, that's what Ruby does, and so on. And if I have a function named f that says I return a return value of type int, and then I return something that is not an int, but a string in this example, then I get a type error at runtime. This is not something that the PHP compiler can detect at compile time. Well, at least it doesn't. For this really, really, really simple case where it's obvious, it could be added thanks to type inference at some point, because I'm returning, I have a return statement, and that return statement doesn't take a variable, but it returns a constant, basically, if you want. That can be detected, but we don't detect that at the moment. That's a runtime error. We talked earlier about the fact that PHP 5 introduced type declarations for function and method parameters for classes, interfaces, and arrays and callables. But PHP 5 did not have support for type declarations for function and method parameters that used so-called scalar types, things like strings, ints, floats. Don't really want to go into too much detail here. If you're interested in how we arrived at the solution that I'm about to show, come to my talk on Thursday, or to the workshop on Thursday. We have much more time there to dig into the history on how we got there. But this is what we have now in PHP 7. We can now use scalar types in type declarations for function and method parameters. We can say, in this example, I have a method named m, and m wants 3 arguments, and the first one is a string, an int, and a float. And the default behavior is so-called coercive, meaning PHP behind the scenes automatically makes sure that I get that an argument of a certain type is coerced, cast, converted into the type that I expect for the parameter. So for instance, if I call this with something that is not a string, not an int, not a float, then PHP automatically converts that, which may or may not be what you want. If you are like me, then you want things to be strict. But if you are like me, then you don't want them to be like this. But this is what we got. There's a second mode of operation for the scalar type declarations. Different semantics for the same syntax, if you will. So if you have in one file the declaration for class C with its method m, and then in some other file you use that class and call the method from there. And if in that other file you use the pragma strict types and set it to 1, which means enable strict type checking, then the type declarations of the scalar type declarations of functions and methods called from this file are strictly enforced. If the type of argument and parameter don't match, there's an error. I would have liked it, if we had to have 2 modes of operations, then I would have liked it the other way around. Meaning, if I put declare strict types equals 1 into the file that declares the class C, that should mean everyone that calls me should be type safe. But that's not what we got. If you want more details on that, come to the thing on Thursday. Okay. So 2 modes of operations. 2 modes of operation for scalar type declarations. This is what we got. Just the day before yesterday, I learned a new term, which is called type terrorist. I'm not at an airport. I'm allowed to say the word terrorist. So advocates for static typing are anti-human because they argue that the only programs we should allow to run are the ones that have been verified by machines. In contrast, the freedom fighters, contrary to these typing terrorists, argue that humans can perform analysis and decision-making as well. So what Jay McCarthy is saying, I want the freedom of an implicitly typed, dynamically typed language because I can think for myself. I do not need a machine to tell me what I'm allowed to run. I know better. And this is a really nice summary of the 40, 50-year, not really war. Some people call it a war because it sounds more interesting. Just like the local newspaper from Frankfurt called yesterday's incident with my plane an emergency landing, where in fact it wasn't an emergency landing. Nothing was on fire. There was no foam. Fire department just had to show up because the redundancy was not given anymore. This is not a war. It's just different opinions. And there is no true answer to what is better. If you use a statically typed language that has a strong type system, you catch a lot more errors at compile time. Yes. You probably need a lot less unit tests. Yes. If, on the other hand, you use a dynamically typed language, maybe with type inference, you get all of the same benefits, but feel better, not oppressed by a terrorist compiler, however you want to look at that, while you're working. But in my opinion, only if you also have a good amount of tests that give you the same checks that the other languages give you at compile time, but at runtime. So take your pick. I mean, you are at a PHP conference, so you probably already know that this feels right for you. But now you know how PHP relates according to all these different aspects of programming language design to other languages. So PHP is dynamically typed. Some checks that can be performed at compile time are performed at compile time. PHP is implicitly typed, weakly typed. It does not require you to use any type of type declaration anywhere in your code. But there are more and more places in the syntax where you can add these type declarations. It started with PHP 5, where we allowed type declarations for classes, interfaces, arrays, callables in method signatures and function signatures. It expanded now with Scalar Types for type declarations in function and method signatures. It expanded with return type declarations. At the moment, there's an RFC to add type declarations to attributes of classes. So you can write things like private int $amount, for instance. And PHP will then enforce at runtime that in that attribute of the object, there cannot be something that is not an int, which reduces a lot the amount of code that you have to put in your code explicitly to ensure this type safety. So I think that's good. Other people disagree. That's why we have RFCs and discussions and votes, so we can figure out what the best way is for PHP to go into the future. And PHP is really in line with a trend in programming language design that's called gradual typing or optional typing. It does not require you to write any of these type information explicitly into your code, but it allows you to do that. And if you do it, then those rules are enforced. So you can mix and match whatever makes the most sense to you. And talking about making sense, I hope that this has made sense to you, was some sort of useful and not boring. As far as I could tell, only very few people left at some point, probably to get coffee, and never found their way back. I hope this was useful. I hope you liked it. I'll upload the slides as soon as possible. If you have any questions, I think we have like 5 minutes or so for questions. No, not really. So I'm here the rest of the conference. Just grab me and discuss. Thank you.